So let's have a look at some of the properties of our integral, how we can manipulate the calculations to make life easier. Some of the basic rules, well, this is what we saw yesterday, really, is that if you want to integrate x to the power of n, we add 1 to the power over the power. The notation, remember, the long S symbol for the integration. And when we integrate then, there's a couple of ways of doing it. Probably the most common way is with the square brackets. And then you put your limits on the right-hand side. Sometimes I have seen people just put a vertical line on the right-hand side with the limits. But that's a bit messy. We don't usually do that. The square brackets is a lot neater, because if you are going to factorise something out, just having a single line, what are you factorising it out of? So we put the square brackets there. Makes life a bit easier. Okay, second rule. This is just basically saying, look, the integral sign is a grouping symbol. It's like any grouping symbol. You can factorise outside of it. However, when it comes to integrals, you can only factorise constants. You can't pull an x out of the integral sign. So that's what that one's basically saying. Only factorise constants out of integrals. Here, not so much with polynomials, but once we start looking at more complicated functions, you can integrate a piece at a time. So sometimes it is easier to get the function and split it up into two separate things to integrate. And so this is what number 3 is basically saying, is it doesn't really matter. You can integrate it all as one function, or you could split it up into two separate ones and integrate it that way. That's for addition and subtraction. Multiplication, you can't do that. This looks really stupid, I know. But what it's saying is, if for some reason C is some number in the middle of A and B, if you were integrating from A to B, you could, if you wanted to, integrate from A to C, then integrate from C to B, and add them together. Because if you think back to the area idea, if we're saying the area from A to B, if C was in the middle, then the area from A to C plus the area from C to B would give you the area to A to B. So it looks really funny right now, but once we look at areas above curves and below curves and things like that, it'll make a little bit more sense why we would want to do something like that. If we know the function is always positive, then the integral will be positive. So if you're drawing the graph and it's always above the x-axis, then the answer should be positive. Whereas if the function is below the x-axis, so if the function value is negative, then the integral will turn out to be negative. Okay? Now when we're talking about areas, and we'll do more on areas later, then we have to take that into account, because obviously you can't have a negative area. But when we're just talking about integration, it's just a value it comes up with, and that's perfectly fine to be a negative number. That's not a problem. Now, the integral of one function will be below the integral of the other one. Again, it comes down to thinking about the picture. If you draw a graph and we draw a function x, and it's always below this other function, so g of x, then the value of the integral for function x should be less than the value of the integral. And if you think about areas, again, that makes sense. I mean, if this function is below, then the area underneath will be less than the area below the curve above it. This can come in handy. We traditionally put the limits a to b. It doesn't have to be that way. You can swap them around. And we'll see situations where it is convenient to do that. But if you do swap the limits around, you're going to turn your answer into the negative of what you want. So if you're going function B minus function A. So if you were to swap the limits around, you'd end up with function A minus function B. So you get the negative of the actual answer. So if you do swap the limits around, to balance it out, you need to put a negative sign out the front. So you get the correct answer. If you've got an odd function, then and integrate from minus a to a, then the answer will always be 0. And this comes down to the idea the area below is negative and the area above is positive. But if it's an odd function, it's symmetrical. So if you're going from minus a to a, then the area above would be the same as the area below, but the area below is going to give you a negative answer. So when you add them together, you get 0. Whereas with an even function, Sometimes we find it useful, instead of going from minus a to a, we say twice from 0 to a. And so both of them might be above the axis. Rather than calculate both of them out, we say, well, we know it's symmetric, so I'll just work out from 0 to a and double it. And why would we do that? Probably because 0 is usually an easier number to substitute into a function. And if you're trying to work out whether something's an odd or even function, it might be a multiplication of several functions. Keep this in mind. Odd times odd will be an even function. Odd times even will be an odd function. And even times even will be an even function. And if you ever forget that, just think back to polynomials and the simplest one. The simplest odd function would be y equals x, x to the power of 1. If you go x to the power of 1 times x to the power of 1, you would get x squared, which is an even function. Odd times even, well, if you went x times x squared, you get x cubed, which is an odd function. So that's how you can keep that in mind. And x squared times x squared would be x to the 4, which is also an even function. This is from some very basic questions, I guess. This one example is, I guess, illustrating. I got a constant 6 there, so I could take 6 outside of the integral. So I'll get 6 lots of, and the integral of x squared, add 1 to the power over the power, a third x cubed. Again, I've got another constant, a third, that I could bring out and change that to 2 lots of, sub in 2, sub in 1, and we get the answer 14. Cubed root of x, we'll have to change that to index form, just like we did when we were differentiation. Same when we're integrating. That becomes x to the power of a third. Add 1 to the power over the power. You get 3/4 x to the 4/3. The way I always remember this when I'm dealing with fractions is I add 1 to the power, then the number out the front will be the reciprocal, because I'm saying 1 over. So I'll get 3/4 x to the 4/3. So I think of the power first, and then I go, okay, now the reciprocal will be out the front. And in this case, we're subbing from 0 up to 5. Well, 0 is an easy one to work out, of course, but I did change it to x times the cube root of x, because we don't know what the cube root of 5 is. So if I want an exact value, I'll leave it as 5 times the cube root of 5. If they ask for an approximation, well, then okay, I could go to the calculator and get whatever that is to the power of 4/3. Remember, simplifying these, think of it as an improper fraction. 4/3 is 1 and a third. So x to the power of 1, x to the power of a third, cube root of x. Hang on, you think he's lost his mind. How on earth are we going to integrate a sine function? We haven't learned how to do that yet. But this example actually is illustrating one of the other facts that I pointed out about odd and even functions. If you think of the sine curve, odd or even? Good, odd. So sine to the power of 5 would be going odd times odd times odd times odd times odd. We will end up with odd. Going great today. So we know what I'm asking here is I'm integrating an odd function, minus 2 to 2, via symmetry, that's 0. Now later on, when we do know how to integrate trig, of course that little trick saves a lot of time. At the moment now, it's the only way we can do it, because we don't know how to integrate the trig. Right. Here's a polynomial. I could break it up into each individual bit. I'm not going to, because look at what I've done. How can I just do that? X cubed plus 2x squared plus x plus 1. I said, oh, well, that's just 2 times 2x squared plus 1. Yeah, again, I'm using the feature of odd and even. Each individual term, I'm looking at each individual term. X cubed is odd. So from minus 1 to 1, that's going to be 0. 2x squared is even. So it'll be twice from 0 to 2. X is odd. So that'll be 0. 1 is even. So I've saved myself a little bit of time. I don't have to worry about integrating the x cubed and the x. Right? So now I've only got 2 things to integrate. So we get 2/3 x cubed plus x, sub in 1, sub in 0, and we get 10/3 as our answer. All right.